Okay, good afternoon, everybody. And today we are in the lab. We were in the lecture in the morning. For some of you, we had them again for something else. And it's been a long day today. Let me turn on the camera. I'm sorry. I'm in the light so that they can see better my stuff. Anyway, the lab, for those who already sit in the other class, they know basically the little bit of the drill. So it's going to be something similar in here. So they have that little bit of advantage, but it's still, so everybody else needs to be on the same basically footage so that you guys also have the same stuff. So the lab, basically how it works for this class is going to be basically a virtual lab, meaning that it's going to be simulation, okay? For the most part, this particular lab, you guys are actually going to be doing stuff at home, okay? And you're going to be uploading things at home. But the simulations down the road, this involves one of two basically kinds of simulations. There is the PHET simulation, PHET, from the University of Colorado, that we sometimes use. I'm not sure if honestly in this class we'll be using them, but I know for the other two people, or I don't know how many people in here, they are sitting in the other class. We use them actually also in the physics for B sequence, okay? Now, also, we use GeoGebra. GeoGebra is basically, I make the simulations myself, basically, and program them, and you guys do the data and so on and so forth. For this class, probably for 4C, it's most likely going to be basically GeoGebra for the most part, if it's not something that you do at home. So this is in general, in terms of how we do things for this lab, okay? During the lab session, which starts at 2 o'clock on Monday and ends at 5:10 p.m. on Monday, the way this thing works is we start the session. It lasts for about maybe anywhere between half an hour, depending on how intensive the lab is, to about an hour, okay, for where the lab is, where we will go together, go through all of the things that are required in the lab. We discuss the things, and then we stop the recording at that point, unless somebody has a question, and leave the session open. I will be around hearing basically what you guys are asking. If there is an issue, you can ask me, and then I can come back in here, give me at most about 30 seconds to sit around, turn on the microphone, and then basically get going with you guys up until 5:10 p.m. Okay, this thing will be until we basically the last person leaves, because some of you probably are done with the lab or understand what the lab needs, or know that probably you need some materials. Like for example, today we know that we need some materials for the lab, so they would want to gather their things, so they basically leave. You don't have to tell me that you're leaving, you can just leave. The last person who leaves after that, I can still end the session, so before the 5:10 p.m., because I assume that nobody has a question. Now, if during the week you still have a question into the lab, for example, please do ask. Do not leave it to the last day when you decide, you know what, I have a lab in this class, I need to go and start doing it. By then, probably it's too late. So think about the lab, you know basically what needs to be done, go through it, do the stuff that is required from you to do, and then do the lab report. The lab report is quite extensive for all of my classes, actually. And it asks a lot of things. It asks you stuff from the background, asks you things that you have to do and things like that, and then finish it. That's why I urge you as much as you can to stick around during the lab, actually, and do it during the lab session, so that you take care of it. Okay, we cannot really do lecture in the lab. If we do it, it's going to be at most an hour and 25 minutes, because after that, it's too hard to do lecturing. Okay, so all of the sessions are designated for hands-on activities and activities on simulations and things like that. Okay, so this is in general how the process works. Okay, any questions about the general things before we get into the instructions for this lab? Okay, if you guys don't have any questions, let me change the view in here, make it into a student view. Why it's not showing me the rubric? For some reason, when I'm going into student view, it doesn't show me the rubric. Oh man. Okay, that's not good. Okay, let me talk about the lab. And for some reason, it's not showing me the rubric. And explain to you basically what needs to be done, okay? And then I will go through the lab instructions and I will post the rubric again because for some reason it's removed from there, okay? Anyway, so let me share with you the screen for the lab instructions. So hopefully you guys are looking at the lab one for the buoyant force, okay? When you come in here, you're going to usually have instructions in here for the lab. Sometimes there will be more than a single file. Right now you have the PDF file. And the PDF file is a tool for you to do your lab report. It doesn't mean that that's the only way of doing your lab report, okay? So technically you could do your lab report using the lab report, this lab report, which is actually a form that you can fill. Or you can actually use your preferred way of writing your lab report, but the components of the lab report need to be there, okay? So let me open this thing and let me download it, actually. Download, because the instructions tell you, and please follow the instructions, okay? It tells you to specifically use Adobe Reader, okay? So you really need to have that Adobe Reader for you guys to use. So let me go back into the lab. So it tells you to get it from here. So if I click on this one, I will get the Adobe Reader. Please use the Adobe Reader. Do not use anything else, okay? I know that sometimes, at least with the new browsers like Microsoft Edge and Chrome, I think they have the capability of basically keeping the data after you write it. But try to, even those, try to avoid them, because once we say open the door for those ones, I know that there are people who use probably Firefox, I think probably can work, especially with the new updates. But the other one from Apple, what is that browser from Apple? Safari. I think Safari has some issues, and even Internet Explorer, the people who still use Internet Explorer have issues for sure. So Microsoft Edge, which is the new version of their browser, I think works a lot better. As a matter of fact, Microsoft Edge and Chrome now, they are one thing. They have the same technology behind the scenes, so either one would work. But don't try to use the Adobe Reader, okay? That solves all of your problems as far as this. And then basically, once you do that, the first thing you should do is open the file, put your name in the lab report, okay? We're gonna talk about team working when it comes to labs. And then save the file, okay? It tells you when the lab is due, and this lab is due, and actually it tells you here too when the lab is due. Please pay attention more to this due date than sometimes the text in here, because in the rush of writing things, sometimes I make mistakes in here. But when I go definitely trying to put a deadline for an assignment, usually it's in here, okay, hard-coded in there. Sometimes I even forgot to put in the instructions what the date is, because it's written in the above in here, okay? Right now it says 0.0, please ignore that. That's not correct, okay? So this is a full-fledged lab report with data. I'm going to tell you exactly how it's going to be graded. I'm going to come back in here and fix the rubric because I must have deleted it by mistake. Okay, so let me stop sharing that screen. Where is it? Stop sharing the screen and share with you the PDF file once I open it. Okay, here is the PDF file. Let me move it to the other screen also. Did it stop sharing? Okay. Share. Are you guys looking at the PDF file? Physics 4C, Lab 1.
Yeah.
Okay, very good. Thank you. So the first thing you do, once you see a lab report like this one, let me change the view in here so that fits one page. The first thing you do in here, when you see a red thing in here, that is a required field. Sometimes it doesn't save without those red fields being required them in fill. So the name in here is required. The objective also is required. Answering those questions are not required, but you're going to lose points. So better answer them. I mean, at least for the sake of this lab report, you may skip, let's say, for example, question 4, I really don't know what the answer to it is. So I'm going to just take the hit for it and go. Okay. So you can do that, but you cannot skip the objective and you cannot skip your name. Those two are required. Okay. And then finally, the other thing that is required is actually the conclusion also. That is also required in here. So that is basically what these things are required for this one. Okay, I will have to rewrite this rubric. I don't know. I think I was looking at it for some reason. It's gone. So I'm gonna put it back. Hopefully, by the end of the day, at most, you will have the rubric in here and how these things graded. Let me explain how these things are graded in general. The lab reports. You will lose 1 point. In here, you will get 1 point for writing your name. You also need to write everybody who worked with you on this lab report. Okay, the last thing I would want to see is while I'm grading your lab report is to see it similar and identical to somebody else, and then both names are only showing one member. Okay. Now, if the other person was kind enough and put your name on their lab report and you did not, that is a problem for you, not for them. They already fulfilled the requirements, so they're not going to lose points. In here, you're going to lose a full point in here. So if you are working with somebody else, please write everybody's name in the lab report, okay? It's actually a very good thing to work together. So you're not going to be shy about the fact, you know what, I worked with so-and-so, and now if I put their names, my work appeared maybe less than what it should be had I done it by myself. No, it's the opposite. Your work will have more value in it if it shows cooperation and working with somebody else in a teamwork. The only thing I require right now because of COVID is the fact that you have to keep your distance apart. If you're working together, I assume that you're working remotely. You're not actually physically together. And if you are physically together, you're observing all the rules in terms of basically COVID requirements, basically that the person has to be safe and basically covering all the requirements that goes with it. So basically, I want you to do it safely too. So that is really what is required. If we are in a classroom environment, if the way I used to do things is, I force my students to work together in teams, number one. And number two, I force them to rotate also so that you don't stay in the same team. Now, how many people can work together? I hope no more than 3, okay? 2 people will be ideal in this classroom, 3 at most. Don't put the entire classroom as some people who work with you. That is not going to work. That's going to be too much of something to track around, okay, for me to have a bunch of people working on the same lab. So 2 people, you put your name first and the name of the person, the second person second. So I'm gonna put DJ in here. That's my name. And let's say, for example, I worked with Justin on this. I'm gonna put Justin, and just to avoid any kind of confusion, if there is another, why it's not typing, Justin. Did I miss the T in here? Okay, T. Okay. And if I have a third person, I'm going to put it, let's say, for example, Micah also was working with us on this lab, Micah T again, okay? So now I have everybody in this lab report, okay? You can put as many names theoretically as you can, but please don't put no more than 3 in here, okay? If you work 3 of you in the lab. Now that's one thing. Once you do that, it's a good idea to go to the objective and put something in there, which is anything. This is a rich text environment, meaning that rich text editor actually, meaning that there is a spell checker for you there. So something is not spelled correctly is going to be fixed. Something that it's not fixed, you have to still fix it. Something that is not spelled fair, you will get those squiggly lines below it, the red marker saying that this is not misspelled. Sometimes it is confusing for it. For example, if you're talking about translational motion, oh no, it accepted it. But sometimes it takes it as being a typo, okay? Some things that are known as science that are good, it doesn't take them. And then come to the conclusion, right? This is my conclusion, just to get going. This is my conclusion. Just before doing anything else, just to test your system, the way that it's working. And in here, just anything in here and put in here your name or at least a couple of letters. And what you do in this case is you come in here to the file and save, okay? And close the file completely and then reopen it. If it persists, if what you wrote there is saved, that means you have a good working environment for yourself, okay? If it does not save, you really have to save yourself from the trouble of going through the entire lab report, working very hard on it, spending about 3 to 4 hours on it already, and completing it in immaculate condition, beautiful settings, everything, the verbiage, the lines, the description, the graph, everything is immaculate. And then you upload it to Canvas, and the way I see it is completely blank. Isn't that a disaster? We wasted so much time for nothing. Yes. I agree. So the way this thing works is at least put a couple of things right now before you even start doing this lab in your lab report, where it's required, save it, and make sure it saves. If it doesn't save, your system is not working well, okay? Whatever you're using is not working, because especially in the fall and the spring of, no, actually before that, I used to even do fillable lab reports way before COVID, okay? So this is not new to me. So I have a lot of lab reports before in the past, but even when we meet in classroom, I give my students the lab report forms and I ask them, this is not a requirement for you, and it's still for you guys that you use them. But if you choose to use them, make sure that they work. So sometimes what happens is they send me, they upload stuff to Canvas and it's all blank. And then, hey, upload a blank report. What am I going to do with it? I'm going to just basically the grade, which is in this case, nothing. Okay. So for your case, you really have to make sure before doing this very same lab, test your working environment to make sure it's working. Do I have everybody on board on this point in here? Okay, so this is key one. Then the grading, as I said, you get 1 point in here for the name. So I'm going to upload the rubric again. Okay, for some reason it gets messed up. Okay. The objective is 3 points if you get it correct. What I need in the objective, at least 2 sentences. What I'm looking for is actually proper English sentences, meaning that you have to check the spelling. Don't put everything in caps. Don't put everything lower caps. Lowercase. Don't address the thing as being I will or I am or I'm going to. That is not the proper tense for any lab report. It doesn't matter. Okay. You can use the word we are going. Okay. Do not say also the students are. That is not correct. Okay. So you can say we are, or in this lab, so and so will be tested. In this case, buoyancy will be tested using this apparatus or this approach. So you can use the third person in this sense, or you can use we as basically scientists are going to test this thing. Okay. So that is the objective. It needs to tie in to your lab activities. Because you just barely started and you read the theory, which is a common big thing in here, you probably don't know what is needed to be done. Usually at a good practice, is to leave the objective toward the end. Now you have a clear idea what you did, okay, for this labs that we're doing, okay? So you're going to basically go through all of the questions up to the point where you're doing your conclusion. At that point, you need to come back and think of what the objective for this lab was, to test what, okay? And once you put it in here, at least two sentences, it should be one paragraph. It cannot be two or more paragraphs. It should be only at most one paragraph, okay? Not at most, exactly one paragraph, okay? You cannot put in here another paragraph and start to being verbose. It needs to be accurate, and it needs to be descriptive of what you are going to be doing in this lab and what needs to be tested, okay? So that you can get the hints from it from the background. Sometimes it's stated in here what you're going to be doing, but that's basically in a nutshell what we will be doing in here, okay, for the objective. Now, if you don't have the two sentences, or if you don't describe accurately what needs to be done, or you miss something in here in the objective that is related to the activities in there, you're going to have 1 point in here. Again, I'm just stating the rubric. If you miss it completely, or you don't have the two sentences required, or it's completely blank, in this case, you're not going to receive any credits for the objective. So that's how the objective is graded. All questions in all the labs are worth 2 points. We have a bunch of questions in this lab, 6, 7 question. What is this one? 10. You have 11 questions. Each one of them is worth 2 points. 2 times 11, that's 22 points. So far, if you're keeping track, the objective was 3, the name was 1, plus 22, that is 26 points so far in the lab, in this particular lab, okay? Other labs, they may have less questions. Sometimes they even have more questions. So the lab number of questions, they vary. Each one of them is worth 2 points. How do we count the 2 points? First of all, do not use a yes or no answer to any of the questions, okay? The questions, for example, is the error acceptable? You're not going to tell me yes or yes, it's acceptable. Both of them are not good. You really have to be verbose in the sense that the error computed in this lab, or the error as shown, is 2.3%, for example. That's what you calculated. And let's say, for example, we set the limit on the error to be no more than 5%. It's 2.3%, and it's way below the 5%. Therefore, it's an acceptable error, and it seems like the simulation is working. So in a sense, you need to be descriptive of what the answer, the question is, okay? If the error turned out to be 6.17%, for example, and the limit is 5%, in this case, it seems like the error is 6.7, whatever, 6.17%, for example, and it's much higher than the required minimum of 5%. This could be due probably to some errors in the equipment or in the simulation or whatever you have. What does this have in terms of implications? And it's probably going to be discussed later on. Maybe there is another question immediately. For example, and I know we're not doing momentum in here, but if we're doing momentum, is the momentum conserved in this experiment? And you would say, okay, because the error is too high, then therefore the momentum is not conserved. That is, if it's question immediately related to it, okay, to this question, or if it's coming in the conclusion, you're going to discuss about that in the conclusion. So that's the question. The question should be a little bit, at least about 2 sentences describing what the question is, okay? What is the value for so-and-so? Do not write 2.3. Let's say, for example, we're measuring, I don't know, the density of the liquid, for example, and it turns out to be 1.2 grams per cubic centimeter. Don't put 1.2 grams. You put the density of this fluid is 1.2 grams per the calculation as shown, or from the measurements as we found, because it's the average value, for example, okay? Okay, so basically, that is, if you guys are going to cooperate somewhere else, please also maybe keep me in the loop too, just in case if there is a question that arises there and you need help with it too. Okay, I know that there is something in the chat right now going on. Keep me in the loop there too, so just in case, I mean, you would want to have a question or something, or what am I going to say? Or if you want me to facilitate that, we'll try to do that too, via Canvas or via other means. Anyway, So that is basically the question. So please keep that in mind. So when you're answering questions, please. And then the other thing also I pick on in any numbers actually that you write in, and this is true for everything that we do in this class. You need units. You cannot tell me the density is 1.2. 1.2 what? Okay. You have to put it in terms of something. You have to relate it, for example, grams per cubic centimeters, kilograms per cubic meters, as related, for example, relatively speaking, compared to that of the water, for example, it's slightly higher than that of the water. So that's basically the things that you need to do. So if the question is missing units, you're going to lose points in it, okay? So if the question is completely a mess and there is nothing in it that describes the question, then you're going to lose all the points in it. So that's basically in terms of the questions. I know probably we don't have a table in this lab in here, but usually tables, depending on the number of cells, they will have a number of points. So if there are 18 cells in it, think of the table having 18 points. I have seen tables that reach points of like 40 or 50 points in them. So that can basically inflate drastically your grade points in here. Usually, if you miss few things in the data that you have entered, you're going to be penalized for that. Okay, you're not going to get full credit, of course, and you're not going to get most of a lot of the credit in here, but you'll get partial credit, and it's going to be in the rubric how much you get if you miss one or more items. Okay, so you have to be very careful in here with your data and the tables. Obviously, if you miss everything or you leave the table blank, you're going to miss all of those points, and that's going to be a big chunk of the grade for that specific lab. Then the other thing also is the graphs. Graphs are usually worth 6 points. Okay, 6 points. The way I graph things, the way I grade the graphs is for the labels on the x-axis and the y-axis, and a clear determination between the independent and the dependent variables. So you really have to make sure that distinction is. That is usually points for it. Also making sure that if there is a trend line that is asked for you, you're going to show the trend line. All the data that you really have are represented in there, not more, not less. Let's say, for example, I have 5 points from my table. What I want to see there on your graph is 5 points, whether you're using Excel or you're using your hand writing or using any kind of a graphing device that you have in there. So I need to see the data in there. And of course, also the scales on the x-axis too, not just the labels, also the scales properly stated in there. So if you're each unit, for example, I don't know, for doing the pressure, for example, each unit is a 1 atmosphere. Its unit is 1 atmosphere, so I need to see the other one as being 2 atmosphere and so on and so forth, okay? So when it comes to that, we have to also have that. Once that's done, in addition to the fact that the graph is correct, you get 6 points. Miss a little and you're gonna have 4 points or nothing at all. So that's basically how the graphs are graded. If you're required to attach a file for the same reasons, you're gonna get 6 points required for that file, whether being a picture, like this lab in here, where you're required to have a picture, or you have a different kind of file, let's say, for example, an Excel file or something that you are supposed to upload or something like that, or an image of an Excel file of your data or graph or something like this. So this is how things are graded up to the point before the conclusion. On the conclusion itself, it's worth 5 points. Conclusion need to at least be, 3 sentences or more. The conclusion can have several paragraphs, as long as the following is met. First of all, it needs to connect back to the objective. So everything that you stated that you need to do in the objective need to be addressed in the conclusion. Did you meet it, or there was a problem with it, or did you do something else instead, or what the issue was, okay? Second, it needs to be representative of the results, namely what was supposed to be verified, especially data in here. That's what I'm looking for. I'm looking for numbers in here, okay? We found, for example, the density of this substance to be this and that substance to be that, or something like that. I'm trying to give an example from this one. And then if there is an error analysis in your problem, we really need errors. So that's what I'm looking for in the conclusion. I'm looking how it's connected to the objective, data in it, with the error analysis, plus of course the structure. In a sense, also it needs to have that specific structure, but it is not using, again, the pronoun I and I or the students did, that is not correct. We did, or this, whatever it was measured, and this is what was found, and so on and so forth, okay? So this is in a nutshell how the lab report, I'm looking for it. I'm sorry, for some reason this rubric was missing in here, but for this one in here, you're supposed to go through all of this, okay? Any questions in general? Okay, so let me ask you, for this lab, what you're supposed to do, you're supposed to go through the theory, okay? And you're supposed to understand these things in here. So hopefully you can answer this question. This lab should be easy. Then for this particular lab, we have this GeoGebra basically link that I have in here for you guys. So I'm gonna click on it. And then once it comes up, I'm going to come back in here to it and show you how this GeoGebra link works, okay? So let me stop sharing that screen. And let me share with you this screen. So this is how the simulation is working right now. Density of 0.5 gram per cubic centimeter. This is just a simulation in here, okay? So this is something that I can change in here. This is a density of almost wood, okay? And it's telling me how this is going to be. So this density right now of the fluid is 1 gram per cubic centimeter. That's most likely water, okay? So if I change the density of this fluid, this is a little bit of a salty water, okay? So salty water, if you take a person, for example, who is mainly water, you and I are mainly water. So this is our density, roughly, okay? So in a salty water, we should be able to float, okay? If you go back into a regular water, this is basically what it does not float, doesn't sink. So this is the idea behind it. But if you put a heavier object in, not a heavier, a much more denser object, you're going to get this much density. So this is the buoyancy basically as we have it in here. For some reason, I'm not showing in here. No. The viscosity is this because, are you guys seeing what this thing is? Let me stop sharing that screen and see if I can move it. Yeah, it looks better on this screen. So let me go back into sharing this screen instead. So which means that your screen resolution may differ, okay? May be different than this one in here. So I probably have to use the lower screen resolution when I'm making these animations. That's probably a good point to remember next time around. Okay, so this is the other screen. Now you see the viscosity of the fluid. The effect of the viscosity is going to move, but a lot slower. Think of this one as sinking inside a honey, okay? With this much density, of course, a honey of density is a lot probably bigger than this one. So, or is it less? Does honey float or sink in the air? No, it sinks, okay? So it's much higher than the air. So again, if I put this element in here, it's going to slowly sink, actually, because it's still less than, it's going to slowly sink. But if I change the viscosity, it's going to sink faster in here until I bring the viscosity down to 0. Typically, fluid like water has a nominal viscosity, okay? It's not 0 completely. So when we did the experiment in class about viscosity being practically 0, that is actually a theory. That is not correct, okay? That is, in real life, there is always viscosity, okay? And then the opacity is how opaque you would want to see the object in here versus the background. And in here, it's giving you the drag and the force, and it's giving you the buoyant force, and it's giving you also the weight of the object. So in this case, because it's in equilibrium, this two must be the same. While it's moving, it's not the same. Of course, it's accelerating. They're different in here. And again, in here, the buoyant force is 9.8, and the weight is 4.9, and the normal force, and I'm sorry, the object weight is this much, the buoyant force, so the normal force is basically the difference between the two, okay? So again, this is just typical animation. At some point, you're gonna be loading iron in here. Okay, 7.8, the density of iron, okay? And changing the density of the fluid to something else and looking at the numbers. So that's basically the questions for this animation. Is this self-explanatory, at least the animation itself? The only thing is you have to go through the questions and basically change this and that and basically report the numbers and answer the questions. Okay, the last part of the lab is making the boat, okay? There is a link in there that you guys are going to go and watch how the boats are made. Last time I made one, and actually I included a picture in the lab report. This is the one I made, okay? Oh, I'm sorry, I'm not showing you my screen. Let me go back and show you the screen. So this is the one I made, okay? Following the instructions, this is very same instructions using the origami basically designed for this lab. You're going to notice that it's going to basically float. I use the bathtub, and you can use your bathtub too. Please include that your setting in there to make sure that you did your lab in here, and try to see how much force it's required for you to sink it, okay? Obviously, the surface in here plays a role, and that's basically how the design is. So it's kind of fun lab, honestly. It's not really a lot of work in it, other than this that simulation where you're supposed to do it. And this is just to get us going. I'm hoping, I'm hoping, I will work so that your lab rubric will be posted so that you guys see that to make sure that it's there. And I'm sorry, I thought I had it there and it was there. For some reason, it's not, it's missing now. Any questions? If you guys don't have any questions, I'm going to stop the recording. I'm going to leave the session open and turn off the microphone. And if you guys have any questions, you just let me know and I will turn on the microphone again. Or you can finish it later on, especially it asks you to do this construction and things like that. So you probably need to gather your stuff and start working on it. Does this sound like a good plan? Okay, so I'm going to stop the recording right now.